Welcome back, Wolfpack. Today we are in lesson 2.5, rigid motions. Our essential question continues to be, what are translations, rotations, and reflections, and do they preserve angles and distance? This should be another quick video because I want to do the bulk of the harder stuff in class. So let's get started with our notes right away. Transformations can be used to determine if two figures are the same. Or we could say if they are congruent. Two figures are congruent, which means equal or the same, if and only if one can be obtained from the other by a sequence of rigid motions. And remember, those rigid motions are those transformations that do not change. I should write word transformations, rigid motions, that do not change the shape or size. So reflections, translations, and rotations, those are rigid motions. Last video we did a non-rigid motion. We did do a dilation. That's a non-rigid motion because it got to change its shape or size. But a rigid motion is something that keeps it the same size, it just moves it around. Let's look at example 1. Use the definition of congruence to decide whether the two figures are congruent, and we're going to explain our answer. So look at quadrilateral CDEF and compare it to quadrilateral JKLM. Do they look to be the same? And it says the figures appear to be the same shape and size, and that we can map CDEF onto JKLM by doing what? What can I do to CDEF? How can I translate it? How can I rotate it? How can I reflect it that will map it directly onto JKLM? And you need to even pay attention to the letters. Okay. C needs to map right onto J because C and J are the first letters. D needs to map right onto K because D and K are the second letters. E needs to map on to L because they're the third letters. And F needs to map on to M because they're the fourth letters. So how can I do that? What reflection, what translation, what rotation? I can't just slide it. I don't think there's a rotation. But if you're looking closely, hopefully you see that I can reflect it right across the y-axis. E, this grid, and this coordinate grid is counting by 2. E is 2 away, because it's at -2. E is 2 away from the y-axis, and L is 2 away. F is 4 away, and M is 4 away. And so on and so forth. So what could we do to map it? Are we reflecting it? And how are we reflecting it? So we would say you can map CDEF onto JKLM by a, you should have the word A right there, by a reflection across the y-axis. If I reflect it across the y-axis, all the points will match up perfectly to each other and they will be congruent. Okay, so let's look at that again. C maps right onto J. D maps right onto K. Okay, 4 to the left of the line of reflection, 4 to the right of the line of reflection. E maps right onto L. And then F maps right onto M. Okay, they're equal distances away from the line of reflection. Since a reflection is a rigid motion, therefore the two figures are congruent. So basically, to put this in simplified words, that if I can place a shape directly onto another shape, it's called mapping it. If I can take a shape and it aligns perfectly with another shape, they are congruent. They are the same size. But if there's any overlapping, or if I can see the other shape at all and they're not perfectly aligned, then they are not congruent. And that's what we're going to do for example B and then example 2, but we will do this in class. So please make sure you have this done. If you have any questions, as always, please make sure you are writing them down, and we will get to them next class. Have a great day, Wolfpack.